All right. Trig ratios. So we're going to learn about those buttons on your calculator that say sine, cos, and tan today. Okay? So you do need a scientific calculator of some sort. It doesn't have to be graphing. Doesn't matter. What we're going to do, though, is we're going to start by reviewing some junior high math, because everything we do today is based on similar triangles. Okay? And the properties of similar triangles. Everything is based on that theory. If that didn't exist, the buttons sine, cos, and tan wouldn't exist. Okay? If the ratios of similar triangles weren't the same, their sides, then this trigonometry wouldn't be a thing. Okay? So we're going to learn about angles, obviously, and side lengths. So here we have, oh, you need a ruler. Should we do this activity? Let's do it. Okay, so I'll give you, okay, so all the angles are the same. So notice how if we look at this triangle right here, that's this big one, this one here, from O to A2 to B2, the ratio, like that, would it still have a 35-degree angle down below? Yeah, it's still 35 degrees. What would this angle be right there? A 90. Would this one be 92? Yeah. What would this angle here be? How would I get that angle? Yeah, Sarah? So they add to 180, so we're going to take them 90 and 35 away from 180, which gives you 65 degrees. Okay, would this angle also be 65? If we look at this big triangle here. Yeah, it would. So these are similar triangles, and so the ratios of their sides are equal to each other. Do you remember that? Coming back to you? Sort of? Okay. So we're going to skip investigation 2 and turn the page and just kind of jump into some stuff. So the first thing we're going to jump into is how do we label a triangle? So we're only studying right triangles, and that's very important that you understand. The trigonometry we're learning about only works for right-angled triangles, right triangles. In grade 11, you're going to study obtuse and acute triangles that are triangles that aren't right. Okay? So, notice, consider the right triangle. Only works for right triangles. That's really important. So, a right triangle will always have two acute angles. What is an acute angle? Okay, less than, an angle that's less than 90 degrees. It's adorable because it's so cute. It's tiny. And why will a right triangle always have two acute angles? It has to equal 180. We already have 90. So these two angles that are left have to add to 90. So it's impossible for one of them to be greater than 90 if we know the sum of the two angles has to be equal to 90. It's just not possible. So it's going to have two acute angles. So when we label our triangle, this is really important. The easiest one is the hypotenuse. Everyone probably already knows the hypotenuse, right? Where's the hypotenuse? It's the longest side of the triangle. The longest side is your hypotenuse. So that would be this side right here. Okay. What's really important to notice too is that the hypotenuse is opposite of the 90 degrees. Because the largest angle will always be opposite the largest side, and vice versa. The smallest angle will have its opposite side will be the smallest side. If you think of an alligator, if I make a small angle, the opposite small, open my mouth, large angle, right? That opposite side is now big. Okay? All right, so that's the hypotenuse. That's the easiest. Now there's two other sides. Have you ever heard of adjacent or opposite before? Yes. Some of you yes, some of you no. Depends if you learned some of this in grade 9, depending on your teacher. Okay, so opposite is literally opposite of your acute angle that you're looking at. So notice we have this, one of them is going to be labeled. We're labeling this, we're looking at the lower angle. So you have to, everything is referenced to one of the acute angles, never both. Opposite of that acute angle will be side opposite. Okay, so that would be your opposite side. AB would be side opposite. Okay, and then the last word is adjacent. Now, what does adjacent mean? Adjacent means beside. Okay, so the adjacent means, that's what the meaning is of adjacent. It means beside. So beside the angle, there are two sides that are going to be beside the angle. One of them is the hypotenuse. The other one, the leftover, is the adjacent. Trigonometry. I really love trigonometry. It's so much fun. You're going to like it, I promise. Maybe not today. Just give yourself time. Okay, so that's how we label a triangle. So let's practice that on these guys. We're going to mark them as hypotenuse, opposite, and adjacent. Do you want to try it yourself? Okay, so based on this angle F, label hypotenuse, opposite, adjacent. Okay, so opposite the angle is side opposite, and then adjacent is beside. Okay, so this guy, where would side opposite be? BS would be opposite, and adjacent. So it all depends on where your angle is. If you change your angle, the labeling of the sides changes. All depends on which acute angle you're looking at. Okay? So there's different ways. We talked about ratios of sides, right? The similar triangles, ratios of sides. We can make ratios of sides, so we can do opposite over hypotenuse. That is called the sine ratio. So we actually have a name for the ratio of the sides. Sine is the ratio of opposite over hypotenuse. The cosine ratio is adjacent over hypotenuse, and the tan ratio is opposite over adjacent. So you don't have to memorize that. It's going to be on your formula sheet. Okay? So let's talk about the triangle. Let's look at just A. Triangle A looked like this. The last question we did. It was D. Here is X. F is here. D and E. Okay, and we said this is hypotenuse, opposite, adjacent. So the sides, opposite divided by hypotenuse, which one was side opposite? We said was DE divided by hypotenuse is FE or EF. It doesn't matter. I like to write it alphabetically, but it doesn't make a difference. You can write FE or EF. Okay, do you want to do the other two? So adjacent over the hypotenuse. So adjacent would be DF divided by hypotenuse, EF. And then opposite, DE over adjacent, DF. Okay? So this acronym, SOHCAHTOA, have you ever heard that before, some of you? Okay? If you have, you're at an advantage in a way, because you've seen this before. I like to write it like this, SOHCAHTOA, because when you write it like that, you can see what divided by what, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So SOHCAHTOA is probably the easiest. Has anyone ever heard other ways to remember? SOHCAHTOA. So that's how we can remember our ratios. However, guess what? You also have a formula sheet. And they're on your formula sheet. Okay? So they are there. You don't have to memorize them, but it's very helpful because if you do have that memorized, it's going to make you a lot quicker. Okay? All right, so really quickly, we're going to find out some sine ratio, cosine ratio, and tan ratios. So the cosine ratio is the ka, so SOHCAHTOA, right? Is the adjacent over the hypotenuse. And so we're looking at angle A. So the cosine ratio for angle A. So you'd actually write that normally as instead of cosine ratio equals, cos A equals, or cos theta equals. Okay? Here this would be the sine A equals 8 degrees. So sine of A would equal to the opposite over hypotenuse, that ratio, the sine ratio. So what's the opposite side? Which side would be opposite? 20, right? Opposite of your angle is side opposite. Hypotenuse, which one's hypotenuse? 29, and which one's adjacent then? 21. So opposite, you said, is 20 divided by hypotenuse of 29. So let's divide that. What does that equal? To 3 decimal places. Okay, 0.6. Let's see, 20 over 29. I'll just do it. 0.6. Oh, to 1. Okay, so to 3 decimal places. This is a good rounding exercise. Be 0.6. Nope, that's 4 decimal places. 90. 90. 690. Okay, cos. Well, cos ratio is adjacent divided by hypotenuse. What's the adjacent length? 21 divided by hypotenuse of 29. So that ratio would be 0.724, 3 decimal places. And the tan ratio, or tan of A, is equal to opposite divided by adjacent. Okay, and you can tell that by SOHCAHTOA. Opposite over adjacent. Opposite, we said, was 20. Adjacent, 21. Or 0.952. Okay? So let's turn the page. Yes? No, this is a great question. I love it. Okay, why do we need to know this? So, the thing about similar triangles, if similar triangles have the same angles and the ratios of their sides are the same, we can use that knowledge of the angle to actually figure out unknown sides, okay, and unknown angles. Because every single triangle that has that same angle, right triangle, that same angle, is going to have the same ratio of sides. So as long as I know, so if I know, for example, that a 35-degree triangle, just say for funsies, okay, let's just, give me a second. Okay, so if I know this, if I know that every 35-degree triangle, right triangle, is going to give me a ratio of 0.574 approximately, okay? As long as I know one part of that triangle, I can figure out the other side. The other, well, the opposite, in this case, because it's a sine, I could figure out this side here. Because I know that x over 60 has to equal to 0.74. Every single triangle that's a right triangle with 35-degree acute angle will have a sine ratio of 0.574. Doesn't matter the size. And so if I know that, then I can figure out an unknown side. Okay? So back in the day, am I recording? Yeah, but that's okay. Back in the day, they didn't have these like calculators like we used to, right? And so they used what they called sine cos trig charts. Kind of trig charts. For sine, cos, and tan. Cos, tan. So let's see if I can find something like this. Open up. That's a lot of numbers, right? So, come on. That's not what I wanted. That's not helping me. Sine, trig, cos table. Let's find another one better. Okay, that's a little better. Can you see it okay? Good enough? Can I click on this and see? Yeah, there we go. Okay? So sine, cos, and tan. So this tells me the ratio of the sides. If you have a right triangle, if sine of 35 degrees, so sine is over here, finding 35 degrees was 35.0, Notice 0.5736. What did I write down? I rounded to 7.4, 3.574. But it's the same one, right? So back in the day, if the ratios of the sides, every single 35-degree triangle, that's a right triangle, will always have that ratio. Now, here's the good news. All these ratios of the sides, given those specific angles, someone took the time to perfectly draw a right triangle with these angles and measure the ratios. And every time, it gave you this certain ratio. So tan table is talking about the adjacent side over hypotenuse, right? Sine is opposite over hypotenuse. No, sorry, tan is opposite over adjacent. There you go. And then cos is adjacent over hypotenuse. So somebody took the time to figure out all those ratios of the sides. If we know that angle and one piece of information only, we can get the other information in the triangle. So thankfully, all of this is now stored in here, your calculator. So you don't have to use a trig table anymore. Those ratios of the sides are already in here for all the given angles. Okay? Which is good news for you. So, and trigonometry is like one of the most useful skills when it comes to like applications in the real world, especially like in the trades, right? So, where were we? Got me excited there. You gotta be careful when you ask questions like that. I might go off on a tangent. No, come on, guys. I was really proud of that one. Okay, so okay, ratios aside. So cos of x degrees would be what? Well, let's label our triangle. Always our first step is labeling opposite, adjacent, hypotenuse. Who's hypotenuse? Was he really? Oh, okay. So 5, the longest side, based on x, who is opposite? 3. Who's adjacent then? I always label adjacent last. He's like the leftover for adjacent. So cosine, what two sides are we dividing with cosine ratio? Nope, that's sine. Adjacent and hypotenuse. So this is where we need to use SOHCAHTOA. It's like you're sucking a toe or something. Or soaking your toe. SOHCAHTOA. Okay. So A divided by H would be 4 over 5. SOHCAHTOA. A. Yeah. I got you. Tan, opposite over adjacent. 3 divided by 4. Got it. Okay? Because it would be opposite side divided by adjacent side. So if we know that ratio, our calculator can actually help us get the angle too. Let's go on. Let's just go on to number 7. Okay? Let's skip 5 and 6. Because we also have to do lesson 2 today. All right. Lesson 2. Hey, it's related to lesson. There's a reason why we put them together. Sine of x. So SOHCAHTOA. So when we're talking about x, I'm going to use 2 different colors. For x, I'll use blue. Okay? So for x, let's do all our x ratios first. Let's label our sides. Who's the hypotenuse? Hypotenuse. 10. Opposite. 6. Opposite of our angle is the opposite side, and then adjacent. So sine would be which two numbers divided by each other? Opposite divided by hypotenuse, which is equal to 6 over 10. Now, if we have a ratio, we always reduce that. So that would be, or a reduced fraction, 3 over 5. Okay. So cos of x, let's go down to cos of x. Cos of x. Cos is what two sides divided? Adjacent over hypotenuse. Okay, so I'm getting that from over here, the SOHCAHTOA part. Adjacent was 8 divided by 10. What does that reduce to? 4 over 5. Okay, so if we were talking about y, what changes? Does the hypotenuse change? No. Does the opposite side change? Yes. Now, if we're talking about y, opposite would be 8, and adjacent would be 6. Okay, that's why I use 2 different colors. So your side of opposite and adjacent will switch depending on which acute angle you're talking about. So what is sine y? Sine of y. Opposite over hypotenuse for y. What's opposite of y? 8 divided by 10, or 4 over 5. And tan of y, which is opposite over adjacent, 8 over 6, or 4 over 3. Okay, we're going to skip this one. Okay, so while you have it open, can you circle some stuff from the next page? So here, 1 DFH, both charts. DFH. Okay, and then turn the page. Number 2, number 3. You don't have to do 4. 5, 6, just C and E. Okay, just triangle C and E. And then turn the page. 7 to 11. Well, 7 to 10, and I believe 11 is optional. Right? 7, 8, 9, 10. And then on the next page, this is optional. Okay? All right, so let's look at lesson 2 now. So we're going to actually try and make this practical use right now. Okay, so grab your calculators. I want you to type in to 4 decimal places each one of these. Okay? I circled this. Example 1. Sine 35, sine 58, cos 35, cos 58. So type them in. 4 decimal places, yeah. Sine. It's sine. It's spelled S-I-N-E. So sine, and then cosine, and tangent. And sine is defined as the opposite divided by hypotenuse. Yeah. But usually we just write 3 letters, so we just drop the E. No, it's okay. Okay. So check that you have the same thing. 8480. Ah, did you get different answers?
Yeah.
Okay, this is very important to do. Okay, you're not in degree mode, right? So, when we're in trig, we need to be in degree mode. So you have to push the mode button. Now that we're actually using those 3 buttons. The only time you need to be in degree mode is if you're pushing those 3 buttons, sine, cos, or tan.
That's what the thing meant on the test yesterday on the front where it says make sure to switch your calculator from radian
To degree mode.
degree or something.
Yeah.
Sorry, I read it.
Yeah, that's okay. So from now on, that actually means something to you, right? And so there's a really easy way to check to see if you're in degree mode. So you want to move over. How you actually change it, you have to push enter. So go over to degree and then push enter. You'll be in degree mode. To check that you're in degree mode, tan 45 has to equal 1. So if it equals 1.6, you are not in degree mode. So tan 45, does it equal 1? Check. If not, put up your hand and I can help you. No, you're right. That was a radian measure. So there are other ways we can actually measure angles. One is with degrees. And the next, well, grade 12 is when you learn about radian measures. Okay, did you get those answers now? So everyone got degree mode? Anyone need help? Okay, come on. Okay, this is a really good question and a great test question. So it's more about the theory behind it. So as angle AOB, so A to O to B. So really when they write it like that, they're really talking about angle O, the inside one, right? From A to O to B is angle O. As it moves from 35 degrees to 58, so say this was both a length of 1, the hypotenuse is a length of 1. Okay, here's 58, and here is 35. It says, why does the sine ratio increase, but the cosine ratio will decrease? Determine what happens to the tangent ratio. So let's think about the sine ratio. Okay, so in the first triangle, sine is opposite divided by hypotenuse. So as our angle grows, what is increasing? Which side is increasing? AB. Do you agree with that? Side opposite is growing. So as the angle increases, the opposite side increases. And so that's why the sine ratio will increase. Okay, if you type in, so what I mean by that, if we type in sine 35 and type in sine 58, we did that on the other page, right? You probably don't remember the numbers, but that's okay. So sine, I'll just write it down for you. 35 was 0.5736, and 58 was 8480. So do you see how the ratio increased? And that's because the opposite side is growing. Okay? Cosine. Talk about cosine. Cosine is which two sides? Adjacent and hypotenuse. So what is happening to the adjacent side? Hypotenuse is staying the same, but what is happening with the adjacent side as the angle increases? It's getting shorter. So the adjacent side decreases as the angle increases. And that's why the cosine ratio will decrease as the angle increases. Okay? Because that adjacent side is actually shrinking. It's getting smaller. In order for us to still have a hypotenuse of 1, and for the opposite to grow, the adjacent has to shrink. So the big question is, what's going to happen with the tangent ratio as the angle increases? So is it an increase or a decrease? Who says increase? Opposite divided by adjacent. 1. Come on. Anyone else? Be confident. Own it. It's no big deal. It's not like your life is resting on it. I'm not going to judge you. Okay. Take a guess. Do you think it's going to increase? Yes. Do you think it's going to decrease? Okay. So we got 2 people answered. Great. A lot of undecided. No one wants to commit unless they know for sure. Hey. Okay. So let's think about this. If the tan ratio is opposite over adjacent, right? TOA. What's happening to opposite? Nope. What's happening happening as the angle grows? What's happening to our opposite side? It's increasing. So the numerator is increasing. Increase, I should say increasing. And the denominator, what's happening to our denominator, our adjacent side as the angle grows? Decreasing. So if the numerator is increasing and the denominator is decreasing, what happens to our ratio? Increases or decreases? Okay, tell me. 6 over 5 versus 7 over 4. Who's larger? Really? You need a calculator for this? Really? Really? Okay. Who's larger? Man, 7 over 4. The numerator is bigger, the denominator is smaller. Okay, notice the increase, decrease. Guess what? That's going to be a bigger number. It has to be. 8 over 3. Is 8 over 3 bigger than 7 over 4? Yes. Of course it is. Is 9 over 2 bigger than 8/3? Yes. Oh, sorry. Because I don't teach grade 6. That's why. I don't know how I do. Okay, so if the numerator is increasing, denominator is decreasing, the tan ratio will increase. There's a very easy way to check your work. Very easy. You take your calculator. Type in tan of 35. Now type in tan of, enter, 58. What happened to the ratio? It got bigger. It increased. Okay? Can you check your work with your calculator? Absolutely. Increase your angle. What happens to the ratio? It gets bigger. Okay? With cosine, you can check cos, oops, that's sine. Cos 35, cos 58. It gets smaller. Okay? All right. That was fun. Your brain hurt? I hope so. Yes. No. Right now? So, okay, with that knowledge, it says without using a calculator, which one's going to be greater? Sine 14 or sine 20? Sine 20. Good. Now, which one's going to be greater? Cos 7, cos 62. Cos 7. With cosine, it's the opposite relationship. Okay, tan, 15 or 75? Yay! And last one, who's going to be greatest? Tan, okay? Tan, because tan is opposite over adjacent. So when you think about the ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Because the hypotenuse is the largest side, and it's on the denominator, this is always going to be less than 0, the ratio. Sorry, less than 1, Johnson. Because your denominator is always going to be larger than your numerator. So like, for example, 49 over 50 is less than 1. It's impossible for your numerator to be larger because the hypotenuse is the largest side. So the same with opposite over hypotenuse. No, adjacent over hypotenuse, that will have to be less than 1. You type in all the angles, cos of 79, cos of 1, they're all less than 1. They're between 0 and 1. But opposite over adjacent, can that be greater than 1? Yeah. So it can be greater than 1. Okay, and so 80 degrees. Let's check our work with that one. Sine 80. Cos 80. We might be wrong with this one, though. No, we're right. We're good. Right? So do you notice how sine and cos is always less than 1? But adjacent over hypotenuse can be definitely greater than 1. Okay, so we need to actually get to some math. Where do we want to go? Yeah, let's look at the next page. So next page. So what does this mean for us in our calculator? So if we know the ratio, we can actually figure out the angles. So check and okay. It says tan 35 equals 0.7. Tan 58 is 1.6. Is there a tangent of something that will equal 1.2? Well, it's going to be between 35 and 58 degrees. So let's do some guess and check. Okay, give me an angle. 40, okay? Tan of 40 equals 0.8. Too small. Keep going. Tan of what? 45. That equals 1. We knew that. Okay, so we need larger. Tan of what? 47. Okay. Oops, press the tan button. That's important. 1.1, we're almost there.
49.
Okay. Oh, could be 49. How about 50? 50 is almost better. Is that better? Okay, let's just double check which one's the best. Yeah, tan of 50 equals 1.2. Is there an easier way to do that? Yes. If you know your ratio, you can actually figure out the angle, and that's by using the inverse button. So the inverse tangent is when you know the ratio, want the angle, and your calculator steps are right here on your workbook. So for example, if I know my ratio of 1.2 and I'm looking for the angle that corresponds, I'm going to push second tan and then put in my ratio. So second tan is 50.19. So the exact angle that actually give that ratio is 50.19 degrees. Well, 19.19442891.
So would you round that down?
With degrees, we always round to the nearest degree. 50. Yeah. Yeah. So let's do this for these guys. If I know the sine ratio and I want the angle A, what am I going to type in? Second sine, and then of your ratio. Okay, so angle A would be the inverse sine of that. Second sine, 0.3584. The nearest degree, that's pretty precise. Okay, so this guy, I want to know angle P. It's as if we want to move tan to the other side to get angle P by itself. So if we think of like manipulation of formulas, the opposite operation is how we move things to the other side, right? So if you had x divided by 2, what would you do to both sides? You would multiply by 2, right? That would be the opposite operation. The opposite operation of tan is inverse tan. And so to move the inverse tan to the other side so that angle P is by itself, we inverse. We take the inverse. What did you get for angle P? 73, good. Okay, did you do these ones yet? Oops. Move my calculator. There you go. So this would be inverse cos 0.5389. What did that equal? 57 degrees to the nearest degree. And a fraction, you can still type in a fraction. So second sine 1 divided by 2 gives you 30 degrees. Okay? Here's your angle. Hooray! Moving on. This is a long lesson. I can skip some stuff. Okay, we can skip 0 and 90 degrees for now. Let's get on to example number, I don't even know if we need to do that either. I'll just go to the so we can draw a line through this page. We're not going to cover that page. And then the second page here, basically our ratios for sine and cos are between 0 and 1. And so I'm just going to look at this question here. Sine of 20. So if you have a triangle, okay, with a 20-degree angle, and sine is equal to opposite over hypotenuse, right? So if this, what would this angle over here have to be? The other acute angle, what would it have to be? No, 70, right? Because it adds to 180. And so the two acute angles always add to 90. There's 90 left over. So this has to be a 70-degree angle. So do you notice how if we have sine of 20 is opposite over adjacent. So if we call this side x and this side y, right? Sine of 20 would equal to x over, no, over, that's not the hypotenuse. What is wrong with my brain? I swear, Brandon's the worst. No, it's, I don't.
It's okay, we're allowed to have that days.
No, I have them every day now.
It's okay, you're allowed. You have another body growing.
I know, and I swear it's like showing in my work. Okay, so sine 20 is x over y. Agreed? Are we good now? All agreed. You have to correct me when I'm wrong, guys. Don't just sit there and like scratch your head.
It's okay, you're allowed.
Okay?
To
So,
okay?
yeah, right? Now, notice that if I was looking at 70 degrees, cos of 70 would also equal what over what? Well, cos, what's the ratio for cosine? Which two sides are we dividing for cosine? SOHCAHTOA. Adjacent over hypotenuse. So for 70 degrees, where would adjacent be? Which side is adjacent? I'll make this a z down here, x, y, z. Okay, which side is adjacent to 70 degrees? X. X would be the new adjacent, right? And hypotenuse is still y. Do you see how they're going to give me the same ratio? Cool, hey? If we switch, so cos of 70 equals sine of 20. Check in your calculator. Type in sine 20. Type in cos 70. Are they the exact same ratio?
Yeah.
Yes, they are. Yeah? Oh, they're just lengths. Length x, length y. I just labeled them lengths. We could have, I guess I could have used vertices, A, B, C. Sorry. They're just the length of that side. Okay? So, sine of 8 degrees would equal cos of what? Notice these add to, what do these add to? 90 degrees. So, cos of 8 and, oh sorry, sine of 8, cos of 82 would be equal. Okay? Now, always be the same ratio because it would just be the other part of the triangle. Yay, we did it, sort of. Okay, so on this page, can you circle the following? D, F, G for number 1, 2 AC, and 3 ADG, and then 4 BEH, and that's it. And you have some time, a little bit. That's it for this one. Yeah. So you might want to go back and work on lesson 1 first. If you want to do this one first, you can. And I'm going to stop the video.